What's up, everybody? Mr. Murray here. Mr. Murray's Mathland, simplifying trig expressions, and just seeing a couple more problems today because, as we've said, this can be a frustrating unit for people because every problem is a little bit different. You can't just do the same thing every time. And so the more problems you see, the more kind of tricks you pick up and tools you add to your toolkit. So let's take a look here at number one, and the directions for today are the same that we've been looking at recently, that we should be able to simplify this to a single term with no fractions in it, one trig function at most. So when I look at this problem, number one, cosine of theta plus cosine of theta times tangent squared. There's a couple things that you could do, and you might be seeing that already, but to me what jumps out is that each of these terms has cosine. So I'm going to factor out that cosine. And by the way, I don't always know what's the best thing to do right off the bat. I'm no different than you guys, just I've had more practice with it. But sometimes I have to try something and see if it goes somewhere. So just remember that. Don't give up. Be persistent. Just use sound algebra. Use all these tricks you've picked up over the years, factoring being one of them. So if I take out that cosine, I now have 1 plus tangent squared. And 1 plus tangent squared, that should look familiar to you. Like we've said, when you have a function that's squared, a trig function, be thinking of those Pythagorean identities. And 1 plus tangent squared is equal to secant squared. That's an identity that we've learned. You should know it, or maybe you can refer to it. You at least know where to look. You're at least picking up on that. And so I'm going to take out those two terms. So cosine is staying right where it is. But I'm going to take out 1 plus tan squared and replace it with secant squared. Okay, so now I've got cosine times secant squared, and I know those can be simplified somewhat because secant squared is equivalent to 1 over cosine squared, right? It's reciprocal function. So 1 over cosine squared times that cosine, that's going to cancel one of these cosines. I'm going to be left with 1 over cosine, which is, of course, equal to secant. And there we go. Got it down to a single trig function, single term, no fractions. Beautiful. So satisfying when that happens, right? Come on, don't lie. I think that's pretty good, and I was thinking if there was another way to do it, and maybe I'd show you that. And I'm sure actually I know there are multiple ways to do this particular problem, but to me that jumped out as the best way to do that one. So feel free to try a different way and see if you come up with the same answer. Maybe you come up with a better, a faster way. Who knows? All right, so number two I'm going to look at is a fraction, and we've got cosecant to the fourth minus cotangent to the fourth. We don't often see things to the fourth power, but we shouldn't be afraid. And it's divided by cosecant squared plus cotangent squared. Okay, so there's all kinds of things you can do. Maybe you're thinking of changing everything to sines and cosines. Maybe the things that are squared in the denominator, you're looking to think of that Pythagorean identity, which the one that uses cotangent squared and cosecant squared is the same one. And that would be 1 plus cotangent squared of theta is equal to cosecant squared of theta. So just be careful, because you can't make cosecant squared plus cotangent squared on the same side of the equation. So I'm going to hold off on that. I feel like it might be involved, but I'm just going to hold off. And now up top, what about those to the fourth? I think one thing I could definitely do is, like we said, to me what jumps out is some major factoring going on. That is a difference of two squares there. And so that can be factored to, right? If you had a to the fourth minus b to the fourth, that could be factored to a squared plus b squared and a squared minus b squared. So in this case, that would be cosecant squared of x plus cotangent squared of x times cosecant squared of x minus cotangent squared of x. Notice how I'm really trying to show my work. I don't have the best handwriting in the world, but I'm trying to be very methodical and show step by step. I'm writing my arguments with each time I'm writing those x's or those thetas or whatever they may be. I'm not just getting lazy and writing little scraps and fragments. Your work needs to be clear. But really, when I do that, this should now say, woohoo, this is going to be something beautiful here, because that entire quantity can cancel with that factor up top. So now, here's where we're at. Now I'm left with cosecant squared minus cotangent squared. Now that's still not one term, that's two terms, and it's two trig functions. But now, because that's a minus, you should be thinking of this identity here that we took a look at in the beginning and said, hey, I could subtract cotangent squared from each side. And there, I've made that expression, cosecant squared minus cotangent squared is equal to 1. So this entire big old fraction at the beginning just really reduced down to 1. And I love when that happens. Some people find it annoying, like, oh, all that work and it just became 1. Thought it'd be something cooler, but unless you're on an AP exam, 1's a pretty cool number. So so there's a couple examples using factoring primarily today, just to get you thinking. So if you have any questions, keep them coming, and as always, be persistent and keep working hard.